Hey guys, I spent a bit more time cleaning up these radio chassis since I did the last video, and it's actually not that bad. In spite of how bad it may have looked in the previous videos, the rust actually isn't all that deep, and the wiring insulation is quite sound. It was really just the power cord and what turned out to be some antenna leads that were really bad. So here's where the antenna leads were. Those I just clipped back. These two things on the back are indeed the speaker outputs. In fact, if you buy an RCA 100, 100A, 103 type speaker, these actually come with the speaker. So there would have been wires coming out of these little plugs here, and they would have gone with the speaker. And then they plug into the back of the radio here. Got rid of all the traces of the asbestos, and I've disposed of it. And now what I'm doing is checking it. But before I could check it, the resistors and whatnot, I had to find some decent service info. It seems like the older the radio is, the tougher that is, which I guess isn't too surprising. So for example, I went to my Beatman's most often needed radio diagrams from 26 to 38, and I found the schematic. This radio is from 1928 as near as I can make out, which is a little bit later than I thought. I thought it was more like 26. But, at any rate, here it is. Now, you may have noticed there's one immediate problem with the service info. There are no values on any of the resistors. Just values on the capacitors. And for the voltage, they just have it for the filaments, not for the rectified DC that powers the radio. And there's no alignment instructions or anything like that, just this very, very basic schematic. So I went online, went hunting for info. I found bits and pieces on the Antique Radio forum, like somebody mentioned some values for some of the resistors, but not a comprehensive set of info. Till I found this, which is a scan of the genuine original RCA Radiola 18 service info. Quality is a little bit low, but the whole thing was there and free download, so who am I to complain? And it identifies all these boxes, so now I now know this is a power transformer, that's filter reactor, and this is combination output condenser, choke, and filter capacitors. And there's all kinds of great info in here about how to troubleshoot the radio, what to do, what not to do. For example, they mention do not pop the 80 rectifier in here and turn this on without this being connected, because without this to load down the transformer, the voltages on the output of the 80 are going to be higher than usual, and you could damage some of the components. Also, the diagrams for the wiring are quite nifty. Oh, and they do give you the voltage readings for those. Higher, for the B+, I guess you could call it. But what I really love is these diagrams. Kind of like a 3D exploded view, combination schematic and actual, like, accurate drawing of what the components really look like. Fortunately, kind of hard to read. Again, they're really close. You can see the colors of the wires are actually labeled there, like green, red, blue, and so on. Power supply unit, or sorry, the socket power unit, that's what they call this thing. The SPU. That one's especially hard to read. So those little squiggles there, those are supposed to actually be the wire colors. Fortunately, you can go through all the service info and they still do not give you the values of the resistors. All they give you are these very crude continuity tests. So you put your probes between like the antenna lead, the G1, and the correct effect is closed, meaning there is conductivity between the two, or continuity between the two, and so on. My thinking is that back in the 20s, the service techs generally did not have an ohm meter or even a voltmeter. They just maybe had some tubes and a crude continuity checker, maybe a voltmeter. So that's why they didn't even bother with it. Also, since these are wire-wound resistors on here, they're not going to drift off value. It's a piece of wire that's got a set resistance. It's not going to change. What can happen is they can burn out, which means they're open. So the continuity check is a pretty reasonable testing method. However, on this chassis, there are some carbon composition dog bone resistors, and those you do need to check, which are these guys here, but as you can see, no values indicated. There's 3 of them. There's 2 there, there's 1 up here. So, back to the hunt. And just a few moments ago, I found on Nostalgia Air, somebody went through and annotated the schematic. In fact, that somebody has a name, William Jeffrey, or Bill Jeffrey, I think he went by. So thank you very much, Mr. Jeffrey, for filling in those missing details. So now we know 43K, 16K, and around about 5 meg. The reason it says roundabout is that is what's called a grid leak resistor, and I don't think the value is really set with the color code on it or anything. It just needs to be in that ballpark, and that's what generates the bias on that number 27 tube. Furthermore, we've got some much clearer, easy to read diagrams on the sucker power unit. And we know the resistances, or at least what he measured. So, I got my ohm meter out. Let's start checking these and see what we get. So R1 should be 1800. And where's R1? Well, first off, I'm going to rotate this around so it matches his diagram. It's the bottom view, so I gotta go like so. Okay, I've got my multimeter handy, got my diagram handy, and I've got it oriented the same way as the diagram. And here are the values that he said he measured. These values I've written in here were values that somebody else had measured and posted on the Antique Radio forum. So I think if we're in the neighborhood of those values, we're okay. R1 is the first section, so it's these 2 terminals. Let's give that a check. And we've got 1633, so it's right in between 1600 and 1800, so I'd say we're okay. Let's check the next section. And we've got 1850, and we're looking for between 1800 and 1900, so things are looking good. And the last section, .418, lower than either one of these, but still, I'd say within reasonable range there. Now, as for checking these guys, these are the resistors that are right across the filament. So, if I try checking one of these, I suspect what I'm going to find is that it's going to be a really, really low resistance. Yeah. So, you may say it should be 56 ohms, however, it's in parallel with this filament winding. And these are low voltage windings, so very few turns of copper wire on this transformer core. So that's going to be super low resistance in parallel with this resistor. So I'm measuring this resistance, not this guy. But because they're center tapped, what I can actually do is forget about measuring it on the outside ends. Let's try measuring it on just one side. And there we've got 13, and if I go on the other side, should have about 13 as well. Okay. So if you add those up, you get about 26. Now the reading is still being affected by this transformer being in parallel with it, but I think these resistors are okay as well. To really check them, I would have to unsolder these wires, and I do not want to do that. So I'm just going to assume that these are okay, and this measured okay. So what's left that we can check? Well, we can check this winding here and this winding. However, we don't know what the resistance should be. But just from experience and common sense, this is a higher voltage than on this side. So the resistance on this side should be higher than this side, because the way you step up a voltage is the ratio of the number of turns. So we're going to have more turns on this side than here. And as for these guys, well, we don't have any values, but again, just kind of from experience, they're either going to be open, a dead short, or some reading, and that reading would probably be in the hundreds of ohms. These are filter chokes. So first off, I want to check this, which is the plates on the type 80 tube, which is this socket down in here, which I think is these two guys. And by the way, that beeping you heard was my multimeter. This model, like many others, they start beeping after you have them on for a while, and then they turn off. What I don't know is, how are you supposed to keep it alive? How do you let it know that you're still using it, other than like turning the range switch around? Because it doesn't seem to be smart enough to know that if you actually connect the probes and get readings up here, it'll still time out, which is just incredibly annoying. Of course, I haven't actually read the owner's manual. There might very well be a way to disable the timeout or extend the timeout. I don't know, but mine times out after, I don't know, like 5 minutes. Alright, well that is a super low resistance reading, so I think I've got the filament side there. So, let's see. There's a one on the other side. The other one is kind of buried underneath all this cabling. There we go. Okay, 358 ohms. That seems perfectly reasonable. Something else I want to try. Let's check the primary side. So these two wires here, that is what used to be going to that nasty old power cord and the power switch, both of which I've disconnected. So if I clip one on here, and one on here, should be somewhere greater than a dead short and less than infinity. But not 8.8K, that doesn't seem right. Now there is this range switch here, so I'm going to try throwing that and let's see what happens. The reading definitely changed, doesn't seem right though. I've got a dirty switch. Okay, now that's different. So was it what, about 2K? Now I'm going to throw the switch again. Now that's what I would expect to see in the primary of a transformer. going 4, 5, 6 ohms, something like that. When I throw it the other way, so either the switch is dirty or there's something wrong with the primary. Because when you throw this switch, I'm checking the resistance here. So when you throw this switch, it should either be here or here. I would just expect a slight change in resistance, like maybe from 4 ohms to 5 ohms or something like that. But not from 4 or 5 ohms to like 2K. And now it's 1K, so yeah, I think this, I mean, imagine the switch has probably been in the same position for like 80 years. It's not too unreasonable to suspect it get dirty. Huh? I may have just knocked that dirt loose. Let's see. One position, 7, 6.8. Throwing the switch. Yeah. A few more times. 4.5 ohms. 4 ohms. Yeah, I think the switch is just really dirty. Now what I can do is, I know that this black wire is the one going over here. So that is this wire. So I know the other two terminals are these two guys. So I can just forget about this, forget about the switch, and just put the clip lead right over here. And let's see. 4 ohms. And what do we have on the other side? 4.2. That's the kind of thing that I was expecting. To be one value that was slightly lower than the other value. So the higher value is going to be the 120 volt position. So when I try powering this up, this will go to one side of the AC input, and the other side I'm going to connect to whichever of these has the higher resistance reading, which I think is this guy. When you get down to this low in resistance, these meters aren't quite so accurate. Alright, I guess it's this. I'm getting like 4.1 here and 4.2 or so on the other side. So it's a subtle difference, but I'll try using that side. Of course, I use my Variac, which I can dial down the voltage on anyways. My concern is I do not want to hook up something like 125 volts out of the wall when this is in the 110 position. In fact, that's in this the service manual. They tell you, just unless you're 100% certain that you've only got 110 volts or lower, always leave it in the 120 volt position, or you do risk damaging this. When I got this radio, it was in the 110 volt position, however. So let's hope that nothing was damaged. Alright, so power transformer seems to be okay, at least with a resistance check. These power resistors seem to be okay. So what else is left to check? I want to check these 3 chokes. And for the hell of it, I'll pull out a capacitance bridge. And let's check these 3 capacitors. Now, it's not impossible for them to still be good. In fact, this chassis sitting right over here is the Radial 80 chassis from my Westinghouse WR8 radio. And when I got this radio, it was playing, even with the old original capacitors. Reason why is that they are not electrolytic capacitors. They are tar block capacitors. There's a big jelly roll of foil and an insulating material, and it's impregnated with tar. So unlike electrolytics, they don't dry out. They can still fail for sure, but there is a possibility the caps are still good. I kind of hope they are too, because you can see in this diagram, the capacitors are inside one of these boxes along with the output coil. And I've already read online one guy who tried to open up this box and recap it, ruined that coil. So if I want to get these caps, if I do want to replace these caps, I guess what I would try doing is leaving the box in place and mounting new caps under here and reroute the connections to it. But anyway, let's check them out anyways for the heck of it.